Today's lesson is going to have us looking at the different functions. We're going to look at linear functions, quadratic functions, which we've talked about in depth this year. We did a lot with linear functions or linear equations in the first semester. This semester we've been working with quadratic functions, which are our parabolas, the x squared, those things that we've been dealing with. And then the next video that we're going to talk about today is going to introduce two new functions, the absolute value function and the exponential function. And it's really just so you kind of start to get an understanding what those graphs look like, what those functions are. Because in Algebra 2, you'll do a lot with those particular families of functions. So we'll do linear and quadratic first because those are the two we know the most about. So if we look at linear equations or linear functions, what is our favorite form of a linear equation? Well, the one that we're most comfortable with, the one that we use the most, is slope-intercept. So y equals mx plus b. And remember that m is our slope and that b is our y-intercept. So the y-intercept tells us where it crosses the y-axis, and m, the number in front of the x, is our slope. So that's our rate of change. And remember that slope is rise over run. Or it's the change in y over change in x. How much does it go up or down versus, or over, how much does it go right? Because remember, we always run forward. So that's our favorite form of a linear equation. So that's the one I'm going to leave here in our notes today. And then what do those graphs look like? Well, the graphs of linear equations are lines. So if we have the xy coordinate plane, we might have a line that's going uphill left to right. And just to remind us, this has a positive slope. But we could have a linear equation or a linear function that's going to go downhill left to right. And that's definitely a possibility too. It's my x-axis, my y-axis, and this one has a negative slope. So just to remind you, you can have a positive slope where your m, or your coefficient in front of x, is positive. That graph is going to go uphill left to right. You can have a negative slope where your coefficient on m is negative, and that's telling you that your graph is going to go downhill left to right. So the next step in all of the things we're going to look at today talks about how can I identify that function or that family of functions from a table. And the way that we can do that is that they're going to have a constant rate of change. Linear functions always have a constant rate of change, meaning they're going up by the same amount every time, or they're going to go down by the same amount every time. And when I say they, I mean the outputs, because if we were going to read our table, our x values are going up by 1 every time, so we're just working our way across the x-axis. But our outputs, our y values, we can see they are actually going to go up by 2 every time. So as I'm looking at this table, I can try to write the rule if I want to. And you may have done this before in middle school. We're going to write this one just because we can. Well, if x is 0, if I just look at this generic graph up here, when x is 0, that means I'm touching the y-axis. So that means if I have the point 0, 2, because if you look at this table, we could think of these all as points. If we wanted to graph them, we could. But if you have the point 0, 2, that's your y-intercept. So that means if we wanted to try to write the equation for this, it's going to look like y equals something times x plus 2, because we know b, the y-intercept, is 2. And then we can use any of these other points to find out what the slope should be. Because if I know x is 1 and y is 4, that has to work in this particular equation. So let's just see what happens. Y is 4, we don't know m, x is 1, And we know that the y-intercept is 2 because we have the point 0.02. Well, if I solve that equation, I get, subtract 2 from both sides, I get 2 equals m. So that means my slope is 2. So this particular table has a rule of y equals 2x plus 2. And I can plug these x values in and check and see if it works. If I put in 2 for x, 2 times 2 is 4, 4 plus 2 is 6. If I put in 3 for x, 2 times 3 is 6, 6 plus 2 is 8. If I put in 4, 2 times 4 is 8, and 8 plus 2 is 10. So this rule definitely works. I don't think on the practice problems today that we're asking you to write the rule for a table, but I just wanted to show you that it's not overwhelming or something that you can't do. But if you are trying to, from the table, decide, is this a linear equation, what you want to look for is to see if these y values are going up by a constant value every time. Here they're going up by 2 every time. They could also be going down by a constant value. So we could have things like 2, 0, -2 if we were subtracting every time. So that's the family of linear functions.